Okay, now we're actually just reversing what I had done on the previous problem. The previous problem gave you the direction angle and gave you the magnitude, and you were trying to find the components. Here you're given the components and you're asked to find the magnitude and the direction angle. Okay, so first of all, finding the magnitude. So if you remember, that's the square root of a squared plus b squared. So we would have 3 squared plus 2 squared, so the 9 plus 4 is going to give me square root 13 to be my magnitude. Okay, now using the formula that we had used earlier, like this was the last example that I worked, but we're going to be using this formula to figure out our direction angle. So in other words, we're going to find out what theta is this time. Okay, so you have this vector that has components 3, 2. So we're going to rewrite it using the formula that we've been using, or that we used a while ago, that I just showed you. Okay, now my first component is a 3, so that means this first component would have to be equivalent to the first component here, because we're stating that they're equal to each other. So what you're going to do is start out by saying 3 equals, and what we're going to do is set it equal to the first part over here. Now we have found that the magnitude of the vector is square root 13, and that's to be multiplied by cosine theta. Of course, this time I don't have anything to plug in for theta. That's what I'm trying to find out, okay? Now, if I'm trying to find theta, I need cosine theta on one side by itself, so I need to divide by square root 13. Okay, so I know what the value for cosine of this angle is. Again, I'm just trying to find the angle. So, in your calculator, if you're trying to find your angle, then you do second, of course this would be second cosine, and we'll have 3 divided by the square root of 13. Okay, so that means that theta is approximately 33.7 degrees. So that would be my direction angle for this example, okay? Now, I used just this portion of it to come up with theta. You can use the second part, so I want to just show you that you can do it both ways. So I'm going to say or. So you either do this or you do what I'm fixing to do over here. You don't have to do the same thing because it's going to produce exactly the same answer. So instead of using the first component that involves the cosine, I could use the sine, okay? So this time my second component is a 2. So you would say 2 is equal to, again, magnitude is square root 13 times sine theta. Okay, so I would need sine theta on one side by itself. So that means that I would divide by square root 13. And at this point, you would put this in your calculator. Of course, this time we're using sine, so you would do second sine 2 divided by the square root of 13. And so you're going to get exactly the same thing. Your direction angle theta is approximately 33.7. So like I said, you don't have to do both of these. They'll both produce exactly the same angle. Okay, now one thing I want to point out to you, if you were to draw this vector off, this vector is located in the first quadrant, because remember the 3 and the 2 would actually represent the end of the vector, like if you drew it from the origin out to the point 3, 2. So when you're in the first quadrant, you know, you can just think about the angle that you've ended up with here would be a quadrant 1 angle, okay? Now, the second example, we're going to do the same thing, but I want you to notice the location of what we have for our vector this time. you have the component form being -2, -5. So if you were to draw this one off, coming out of the origin, the end of this vector is actually going to be in the third quadrant. So you've got to keep that in mind whenever we're actually finding our angle, okay? It's really only going to affect the part where we actually put it into the calculator is where it's going to end up affecting things. Okay, so you're going to start out by finding your magnitude. So again, square root of a squared plus b squared. So that'll give us 4 plus 25, so that means that I have the square root of 29, okay? So I have the vector -2, -5. Of course, this is my formula that this is equivalent to. Okay. Now again, you only have to do, you remember, just half of it. So you can do the -2 equal this part or the -5 equal this part. You don't have to do both. So I'm just going to go with the first component. So I'd have -2 is equal to, now we found the magnitude to be square root 29 cosine theta. And then you're going to divide by square root 29. Now, the fact that this value is coming out here to be negative is what's causing a little bit of problems here as far as doing the calculations in our calculator. Now, I've already mentioned, let me just go back up here a second, that this is located in the third quadrant. So like if you have -2, -5, this vector is coming out here, okay? All right, so our direction angle, remember, is measured from the positive end of the x-axis, okay? So you would expect that this angle here, theta, would be somewhere between 180 and 270 degrees. But if you were to put this in the calculator, just like we did with the other example, of course you do second cosine, and then you have -2 divided by square root 29. Then you notice you get 111, but 111 is second quadrant. So here's the confusion that the calculator has. You're putting in a negative value, but cosine is negative in the second quadrant and the third quadrant. So like your calculator doesn't know which angle it is that it's supposed to give you. Your calculator's programmed based on those restrictions that we learned when we studied the inverse trig functions. And if you remember, your inverse cosine was restricted to the first and second quadrant. So that's why when you enter in a negative value, it's going to produce an answer out of the second quadrant, not the third. So you need to think about where this is, the vector is actually located at, okay? So here's what you're going to have to do. You're going to need to enter this in just as a positive. So let me just come over here and delete my negative. So it's going to now give me something in the first quadrant, but then I can use this as my reference angle, okay? So my reference angle is going to be about 68.2. So then if I want third quadrant, you remember your rule for third quadrant is do 180 plus the reference angle. So 180 plus my reference angle is going to give me an angle of 248.2 degrees. So this ends up being my answer, okay? So if you want to, you might want to make a note that from here you get your reference angle. Do not enter negative. Okay, now, you can use the -5 equal this half, and you're gonna have to handle it exactly the same way, and you'll still get exactly the same angle when you do that.